So lesson number 6 looks at graphing linear equations without the use of technology, using the given equation forms. So if I'm given the general form of a linear equation, how could I use just that equation to draw the line? How could I use the slope y-intercept form to draw a line? How could I use the point slope form to draw a line? Okay? So if we look at class example number 1, and we start off with y equals 2x plus 4. First of all, which form of the equation is this? What do we call this form? Slope y-intercept. And it's called slope y-intercept because the equation contains the slope and the y-intercept. So which one is the y-intercept? 4. That's the part that we're going to start off with. We're going to graph that point. So it crosses the y-axis at 4. Once we have identified the point, we can now use the slope. In this case, the slope is 2. So in terms of rise over run, that means that I would have a rise of 2 and a run of 1. Okay, so it's not that there is no run, the run is 1. So that means I can go up 2 into the right of 1, up 2, right, up 2, right. Or if I went down 2, which direction would I have to go? Left. Okay? So if I draw this using a ruler, because this is supposed to be a straight line, so I would use a ruler, and there would be my points. Okay? So if I look at B, what equation format am I given for B? So slope point form. So when it comes to graphing a linear equation, it's a straight line, I need 2 points. So can I use this equation to give me at least 1 point? What would be the point? If this is in point slope form, what is the point on this equation?
1, negative 1 and 2.
Negative 1 and 2. Because remember, in point slope form, it's x minus x1. Okay, so to get back to question B, with my point slope form, remember, this is written as x minus x1. So in order to get that x minus into a plus 1, it would have been x minus negative 1. And then the y minus y1 is why this point is negative 1 and 2. So if I plot negative 1 and 2, then what can I do from that point?
Use the slope.
Use the slope. Again, the slope is 2. So up 2 over 1, up 2 over 1, up 2 over 1. Use a ruler to draw this as a straight line. And there's my equation. Okay. The last one is a little bit trickier because the last one's given to us in general form. So we don't want to rewrite this in slope y-intercept form. We don't want to rewrite this into point slope form. We want to leave it as general form. So when we have general form, the easiest thing to do with general form is to find the intercepts. So we're going to find the x-intercept, where it crosses the x-axis. How do I do that? Let y be equal to 0. So if y is equal to 0, this negative y will disappear, and I will get 2x plus 4 equals 0. And then I can solve for x. So to get x by itself, I have to get rid of the 4 first. How do I get rid of the positive 4? Subtract 4 on each side. So I would get a negative 4 on the right-hand side. And then to get rid of the x, I would divide, sorry, not to get rid of the x. To get rid of the 2, I divide by 2. Thank you, Tyrone. And I get x equals negative 2. So I get the point negative 2 and 0. And then I can do the same thing finding the y-intercept. So I let x be equal to 0 this time, which means that 2x would disappear, and I would get negative y plus 4 equals 0. I want the y by itself, but I also want the y to be positive. So if it's negative on the left-hand side of the equation, what would it be on the right-hand side? Positive. So we're going to bring it over to the right-hand side where it will become positive, and I get that y equals 4. Right there. All I need is 2 points to join together to make a straight line. I use my ruler, and I join those 2 points. And now I have my line. What do you notice about these 3 lines? They're the same line, which means these 3 equations are the same equation. They're just written in different forms. This equation right here, if I put the y to the other side, I get 2x plus 4 equals y. And with this equation, if I remove the brackets and then collect everything onto one, or isolate the y, I will get 2x plus 4. Okay, so if we quickly summarize what we did in each of these, for the first question, we started off by plotting the b value, which is the y-intercept. And then from that point, you use the slope 2 to draw the next one. With the point slope form, we identified the point, so we plotted it. So we plot negative 1 and 2, and then use the slope to draw or generate the next point. And then in general form, I find out what the 2 intercepts are, draw the 2 intercepts, and then I can label them. Now, you're not expected to be able to draw a line from these 3 equations all the time. If you find it easier to take that point slope form and write it in y-intercept, slope y-intercept, then go ahead and do that. If you find it easier to take the general form and write it in y equals so that you can plot the y-intercept and the slope, then that's what you do. You find the method that works best for you. And sometimes some methods work better than others. It depends whether or not you're going to get fractions in the end. So if we look at the next example looks at matching the equation to its graph. So what is going to make it easiest to match these equations to the graph? What would help me do that? Knowing my intercepts? So you're saying I should go in and figure out what the x and y intercepts are to every single equation here in the list?
You can look at the slopes.
Can look at the slopes. Do I know what the slope is in equation number 1? What should I do in equation 1 to help me out?
Find 2 points.
Easier than finding 2 points. Do I have to keep it in general form? I don't need to keep it in general form. Could I write it in y equals form? So if I went to write it as a y equals, because in this case here the coefficient on y is just, in this case it's a -1, but it's only a 1. And if it's negative on this side, it would be positive on the other side. So I could rewrite this as 2x plus 3 equals y. What equation form do I have there? The slope y-intercept form. So what is my y-intercept? Positive 3. So if I look at my graphs, A is positive 3, B is positive 3, and D is positive 3. So I've eliminated C. Okay. What else do I know about this graph? The slope is 2, which means it is positive. And what way does a positive slope go? Up. It goes this way. So A gets eliminated, so that leaves me between B and D. Now I need to check which one has a slope of 2. So up 2 over 1 leads me to another point. Whereas this one, up 2 over 1, I'm not on a point. So this would be graph D. Okay? If I look at equation number 2, it's already in my slope y-intercept form. And it also has a y-intercept of 3. So I already have D taken off my list. So now I'm choosing between A and B. Why is it A? Negative slope means it's pointing down, so that has to be A. What kind of equation do I have with equation 3? Slope point form. So what is the point on this equation? -4 and -1. Okay. D and A are already used up, so now I'm left with B and C. So I look, does the graph exist at -4 and -1 for both B and C? Only on C. And what's the slope of C? -1/2. It's negative, which means it has to be going down. So that eliminated B from a choice. So I didn't even actually need the point. I could have looked at the slope and said it can't be B. Okay? So that leaves graph B having to be equation 4. And I could double check this. What I could do is I could put the x and the 6 to one side, which would make them positive, and then divide everything by 2. So that would be half of x and 3. My y-intercept and my slope, 1/2. Or with this one, I could find out what the two intercepts are. If x equals 0, I get 2y minus 6 equals 0. And I can look at that and probably figure out that y equals 3. If I let y equal 0, I get -x minus 6 equals 0. So I get that x, because I'm going to move that -6 to the other side, and I'm going to get a positive 6. -6 and 0. So there are my 2 points. So there are different ways that I could go about trying to find out which equation matches to which graph. So it says, explain the strategy that would be used to graph the linear relations y plus 8 equals -5 times x minus 2, and the equation 4x minus y plus 9 equals 0. So what would I do to graph this one?
Put it into y-intercept form.
I have to put it into my y equals form. So I have to isolate for y. How do I do that? So what would I have to do to get y by itself? Subtract the 8. Get rid of the brackets first. So if I get rid of the brackets, what do I get on the right-hand side?
-5x plus 10.
Okay, and then I would subtract my 8 plus 2. So that's what I would put in for my y1. Okay. And what would I do with my 4x minus 9 plus, or sorry, 4x minus y plus 9 equals 0? move the y to the other side. And I can let that be equal to y2. So I would put those into my calculator. So y1 equals negative 5x plus 2. Reminder that for my coefficient of negative 5, it would be this negative right here, not the minus sign. And then 4x plus 9. And if I graph this on a standard window setting, zoom 6, there's my first line, and there's my second line. So what I could do is I could adjust my window settings to see my intercepts a little bit better because it's not quite as clear in here. So my x's, I probably don't need to be as big. I could go from negative 5 to a positive 5. My y's, I don't need to be that far into the negatives, so maybe I could start at negative 3. And then 10 is probably good because I did get to see where it crossed both. So if I try graphing it again, there's my first line, and there's my second line. So I can see where both cross. So your appropriate window settings, I start off by listing my x's, and I put it in the order that I see when I press my window. So min, max, and scale. Negative 5, 5, and 1. And then my y's, the same thing. And I think I went from negative 3 to 10, going up by 1s. So then if I sketch these two graphs, negative 5x plus 2 looks something like this. And then 4x plus 9 looks something like that. And what I would want to do is I'd want to label each of these lines. So the line that I have in blue, that's the one that I would label negative 5x plus 2. And the line that I have in green, I would label as 4x plus 9. So if I had to determine the x and the y intercepts of 4x minus y plus 9, how would I find the y-intercept? Let x equal 0. So on my calculator, how can I use my calculator to find that x-intercept? Trace 0. Now when you've got two equations on here and you press the trace button, the equation that you're on, that the cursor's on, shows up in the corner. So if I wanted to go to the other equation, I could press the down arrow. Now I'm on my 4x plus 9, and if I press 0 and enter, then it gives me my y-intercept of 9. Graphing calculator to find my x-intercept.
Second trace 0.
I find the 0. So again, second trace 0. And again, it tells me that I'm on the y1 graph, so I would have to go down to be on the y2. And then I need to be on the left side of that x-intercept, which is going to be in the negative y's. I press enter. Then I need to move to the y side, or to the right side, which is the positive y values. Make sure the arrows point. And what do I get? Negative 2.25. And if I change that to a fraction, I would get negative 9/4. Which would be the same thing as if I had let y be equal to 0. I get 0 equals 4x plus 9. Bring the 9 over, it becomes negative. Divide by 4. And there's my negative 9/4. Okay. The questions for this lesson